now we are going to start our next chapter, that is recursions. So recursions is a very important chapter, very important chapter when it comes to placements and interviews. And the interviewer might ask you like direct problem of Fibonacci series or any kind of tiling problem or friends pairing problem. These are the like famous problems for recursion topics, and these are the basics of these are the fundamentals for our upcoming chapters. So recursion is the base of our upcoming chapters like trees, graphs, DP, and all those things. So understanding recursion is very important, and I want to tell you one thing, that if you study recursion perfectly, that you understand the concepts of recursion and what is going on and how we do recursion and why we do recursion or when we do recursion. If you understand these sort of things, then I can guarantee you that you will become a excellent programmer. And personally, if you study recursion topics in deep, then you will understand and you can see that you will see the growth in yourself, right? So recursion is a very important topic, and if you master the recursion topic, then you will become an excellent programmer, and you will start to think on your own that how I can solve or how I can approach a particular given problem. What is the correct way, what is the wrong way? You can be able to differentiate the correct way and the wrong way to approaching a problem. So recursion is a very important chapter, and it is an excellent chapter. I'm telling you that you are going to love this chapter, right? From my perspective, this is my favorite chapter, because this has this is the fundamental, this is the fundamental, and these recursion topics or recursion methods is used in topics like trees, graphs, and dynamic programming and all those things. So remember guys that recursion is the base for like complex topics like trees, graphs, and all those things. So understanding recursion is very important. So I want you guys to listen to this chapter carefully and understand and make your notes on your own, such that you will understand, you can revise the things which we are going to discuss in the upcoming chapters. So with that being said, now let us start this chapter. Now let us understand what is the meaning of recursion. So mathematically, we used to write functions, right? We know that we describe a particular function like this. So let us consider a function that is f of x is equals to x square, right? Okay, f of x is equals to x square. This is a particular function. Now, can I write our function? This is known as domain. This is known as domain, and I'm going into like mathematical terms of it. But you don't, if you're not a mathematical student, if you're not from mathematics background, then this doesn't matter to you, right? So this is, you can imagine as this is the input. So f of x is equals to x square is a function. So I can write my function as f of x, f of x. Right here, I'm calling my function. Here, the inside parameter is the function itself. So this thing will give f of x square. So if f of x is equals to x square, then x square, that is x square, then f of x square will give x square whole square. That thing will give me 4. Let us take example that x is equals to 2, then f of 2. So f of 2 is f of 2 is equals to, what is f of x? That is 2 square, right? That is x square, that is nothing but our 2 square. So this thing will give me f of 4. So what is f of 4? F of 4 is 4 square. So this thing will give me 610. So f of 2 is known as f of 2 will give me value as 16, and this sort of thing is known as recursion. So calling our function, a function calling itself, that is known as recursion. Now let us take another example. Right, in previous questions, in previous chapters, we have studied right how to calculate a factorial of a given number. Now in mathematical terms, I am going to represent it. Let us consider that I am calculating the factorial of an n number. So I can write that my f of n, that is factorial of nth number, is equals to n into factorial of n minus 1, right? And I can write this function, this f of n minus as f of n minus 1, factorial of n minus 1 is equals to n minus 1 into f of n minus 2. Yeah, this is also absolutely correct. So I can write my function, that is f of n minus 2 is equals to n minus 2 into f of n minus 3. Yeah, right, okay. So can I write my f of n minus 3 as f of n minus 3 is equals to n minus 3 into f of n minus 4, and this process will continue up to we get f of n minus 1, that is 1 into f of n minus 1, that is f of 0, and at f of 0 we already know that 0 factorial is equals to 1. So this thing will give me 1 into 1, and we will return the value, and by returning the value we can able to calculate our f of n minus 1 factorial. Now let us take example to understand this. Now let us consider that f of 5. So let us consider that I don't know the factorial of 5, because let us consider that I don't know the 5 factorial value. So if I don't know, the concept of recursion is, first of all, if you don't know the answer for a huge problem, then break it into small pieces, right? Break it into small tiny pieces, and combine those by finding the solution for those small pieces. By combining those small pieces, you will get the solution for your large problem. So this is the basic concept of recursion, and this sounds like familiar to integration. In integration we also do the same thing, right? To calculate the area of a particular given curve, we can't able to find like right away the area of curve. We right, break it into small rectangle pieces, and we'll add them together such that we'll get the area of the integration. So if you're not from integration background, then leave these things. So the main concept of recursion is, if you don't know the problem, the answer of a huge problem, then break it into small pieces and try to find the solution for that particular small piece. So if you are able to find the particular small solution, the small problem solution, then just combine with all those small tiny pieces, and by combining you will get the final answer of your huge problem. Now let us consider that I want to calculate the 5 factorial, and I don't know, because this is a huge problem for me, because I don't know how to calculate 5 factorial. So what I do, this is my 5 factorial, right? F of 5. So I will write, I already know that my formula, that f of n factorial is equals to n number, that is the number itself, into f of n minus 1. So I try to find out the factorial of f of n minus 1. So what I will try to find, I will try to find the factorial of, that is n minus 1, that is 4 minus 1, that is 4. So I will try to find out the factorial of 4. So I don't know the factorial of 4. So what I can do, I can write 4 into factorial of 3. Yeah, but I don't know the factorial of 3. So I can write 3 into factorial of 2. Yeah, but I don't know the factorial of 2 also. So can I write that factorial of 2 as 2 into factorial of 1? But I don't know the factorial of 1. So can I write as 1 into factorial of 0? And yeah, I do know that factorial of 0 is equals to 1. So here I will multiply 1 into 1. So this thing will give me 1, that is 1. So I will return to my like upper program, or whatever the previous call program, right? Previous function. So this thing will give me, I already know that this thing will give me 1. So this thing into 2 into factorial of 1 is, from this I have calculated that this thing will give me 1. So final answer will be 2. After this thing will get like this thing will get here multiplied with the answer, that is 3 into 2. So this thing will return me 6. So the answer here, 4 factorial, 4 factorial is equals to 4 into 6, that is 4 factorial is 24. So I will return the answer to my 4 factorial, and the final answer will be 5 into 4 factorial. What is 4 factorial? We already found out that the 4 factorial is 24. So the answer will be 120. So the 5 factorial value is 120. So calling our function, right, I am going to call my function itself. So a function which is calling itself and calling, the calling continuously happens until we reach a base case. What is base case? At small tiny piece, I know that particular solution. Those particular small tiny piece, or you can say that small problem solution, I know. So that small problem, that thing is known as my base case. Here f of 0, I already know that for this problem, that is 0, for finding 0th factorial, I already know that the answer is 1, right? If I know that small tiny piece problem solution, then that thing is known as my base case. So remember guys that a function which is calling itself, this process is known as recursion. So a function recursively calling itself, that is known as recursion. Okay, and in recursion we have a base case, and from the base case we can able to find the solution of a small piece, and by combining all, you can see that I have passed 1 factorial, 2 here to my previous call function, calling function, and I have calculated 2 factorial and passed to 3 factorial, and I have calculated 3 factorial and passed to 4 factorial, and from 4 factorial to 5 factorial, and finally I got my desired answer, that is finding my 5 factorial. So this is how recursion or recursive function takes place, right? How this is how it will take place. And there is one important thing I want to tell you, that there are two directions. There are two directions in recursions. You can see that first of all I am going inside of my function, and second direction is I am coming outside of my function. So the first thing is top to down, right? I am coming from the top to down. I am breaking my big question into small piece, small piece, small piece, small piece, and finally I am finding the solution for the smallest piece, and I am returning towards the big piece, big piece, big piece, and from the small piece I can able to calculate the big piece or big problem for my question, right? Okay. Now from first direction is top to down. Here what I am calling, here I am traveling towards the base case, towards the base case. So from top to down, you can see that from a huge problem I have been reducing my problem to my base case. So if I got my base case, then I will start to expand again. So this thing is known as solution. This second direction is known as solution combination. So whatever the solution I get, I am combining to get my final output or final solution. So second thing is known as solution combination. So these are the two steps that are involved in our function calling or function recursive step. So these are the two directions that are very important. That is, first of all I am breaking my problem to my smaller pieces and I am expanding from it. Now let us go into the definition of recursion. Recursion is a method of solving computational problem where solution depends on solutions to smaller instances or smaller pieces. You can write here smaller pieces of same problem. You can see that for finding 5 factorial I have calculated 4 factorial, for 4 factorial 3 factorial, 3 for calculating 3 factorial I want to calculate 2 factorial, for 2 factorial 1 factorial, and 1 factorial for 1 I have calculated 0 factorial. So you can see that the thing which is going on, that is calculating factorial, those things all are similar in all over the program, all over the function. What I am finding the factorial of a given number. So you can see that the thing which I am going to calculate is similar throughout the function. So that is known as similarity. So here in recursion we are doing our problem on a similar things, and we are going to break our small huge solution into small pieces, and from the small piece we can able to find our big solution. We have to believe that, right? My small solution, right? If I don't know the 5 factorial, then I will call for 5 factorial into factorial of 4, and you have to believe that my 4 factorial, that is my calling my 4 factorial function will return the 4 factorial, and after it 4 factorial will call f of 3, and you have to believe that my 3 factorial will return the factorial of 3. So you just have to believe, and there are 3 things which are very important when it comes to solving recursion questions. In previous chapter, in pattern chapter, I told you, right, there are 3 things in like pattern solving any kind of pattern problems. Similarly here we have 3 things or 3 statements which you have to remember to calculate or to do any kind of recursion questions. That is, first thing is base case. Basis. So you must have to know, that what is my base case. So if you don't know the base case, then our function calling will continuously start, and these will impact, or this will result in stack overflow. So we will study about stack overflow in the next video. So you should know what is your base case, what is your final case, what is the minimum problem solution that you already know. So by finding or by knowing the solution of the smallest piece, you can able to find the largest piece or largest problem of your given question. After second one is work. In the function calling, what work you are performing? Here I am performing 5 into factorial of 4. Here I am performing 4 into factorial of 4. Here what I am performing? I am performing multiplication operation with my integer into my function call. So this is how the work I am defining. So you should be very clear. What is my base case? Second one is what are the work I am going to do in my recursive function. And the third one is function calling, inner function calling, inner function call. That is, I am calling f of n minus, right? So you should know that why I am calling, you should know the logic, right? Why I am calling this f of 4. So to calculate a function of a particular factorial of a given number, I need to know f of n minus 1. Here, that's why I am calling this kind of inner type function, inner function calling, right? That's why I am calling this recursive method, right? Here you should know that these three things, right? What is my base case? What is the work I am going to do, and why I am calling my inner function like this? Why not the other way, or why not this particular way? So you should know these three things, right? By knowing these three things, you can understand, or you can go through like many of this question, right? Remember guys that what is recursion, and what is recursion? Recursion is nothing but to calculate the huge problem, we break it down into small pieces, and we reach our base case, and from the base case we will combine all our solutions to get our final solution, right? So in memory, this is the recursion happens in the form of stack, like I am drawing this in a general way. So this is my main program will call my function, and my function will call again the function itself, the same function. After it will call function, and another function will also call the same function. After the function will call the same function until I reach base case. So if I get the base case, then it will return some value. After it will return some value, and this will also return some value, and finally I will return to my main program, and whatever the value I have written here, that should be my solution. So this is how recursion concept works. So before we do the questions, or learn the concept, what is going on in recursion or how recursion works, you should know two concepts. You should already know, right? You should have been studied. You should have studied two concepts that are, first one is iteration. Or in other words, you should know about loops, right? You should already have studied like loops, what is for loops, what is do while loop, what is while loop, and if you studied these three things, then well and good. After that, second one is how we call a function, or what is function declaration, definition, or calling, or how we call a function, or how we give parameter, how we pass array. So if you know these two chapters, then we are luckily ready to do our chapter recursions. So I want to tell you one more thing, that if you know iteration, iterations, and recursions. Recursions are like siblings. So you can solve any given problem using iteration approach or recursion approach, right? If the interviewer particularly asks you that you have to do this problem using iteration approach only, then only you should proceed with iterative approach. If the interviewer asking you that you should do this particular question using recursive method only, then you should proceed with recursive approach only, right? Whatever the questions we are doing in recursion chapter, you can do those questions using iteration method also. So whatever the questions we did in iteration chapter, we can do this using recursion approach. So if a particular question is being solved by iteration, then it can also be solved by using recursive approach. So you can solve the given problem using any one of these two. So based on our scenario, and based on our approach, which is the based on our difficulty, if that particular approach is easy for that particular question, then we will proceed with that particular question. Suppose for trees, for searching a node in my tree, or searching level wise traversal, I will use recursion approach, because it is like kind of easy, whereas iterative approach is like kind of hard for searching or level wise traversals for my trees. So for that, in some scenarios I will use recursion, and in some questions iterative approach is very efficient. So depending on the question type, or depending on the way question asked, we use iteration or recursion for that particular question. I hope you have understood. To do this chapter, you should know two chapters before, that is iteration and functions. If you studied like iterations and functions, then you are good to go, right? Let us talk about the approach for this question. So we need to print the numbers in decreasing order. Let us consider that user has given me 10, then I need to print 10, 8, 9, 8, 7, 6, 5, 4, 3, 2, 1. So in this fashion I need to print my output. So what is the approach? What is the recursive approach for this question? right? I told you that there are three main things in our recursive topics. These three conditions you have to remember, right? The first condition is a base case. What should be your base case? Second condition should be work. What work you are going to perform in our recursive approach. And third one is how we are going to call our inner function. So these three things, if you are clear, or right, for a particular question, if you are clear with these three things, then you can solve any given question. Now this is my given question, right? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, right? Okay, now I need to print these numbers in decreasing order. So what is the approach, or how I can approach a particular question, right? Suppose user has given me 10, then in the let us consider that this is my function public static, I'm printing, right? So void decreasing number, right? In this I'm passing my value of n. So first of all, in this question, whatever the user has given me value, I need to print that value. So let us consider that this is my output. So first of all, I need to print my value, given value, right? So I will print my value and I will call my a dec n minus 1. So for n minus 1, I will print n minus 1, that is I will call dec 9. And for dec 9, I will first of all print 9 here. After that, I will call dec n minus 1, that is dec 8. Right? So I will when the n value is 8, I will print 8. After that, I will call dec 7. Right? When the dec 7, when the n value is 7, I will print 7. After that, I will call dec 8. Dec 6. So I am going to decrement the value at each function call, right? I will print 6 here. After that, I will call, after printing, I will call dec 5. So here I will print 5. After that, I will call dec 4. Right, here I will print 4, and these process will get continue until my base case, until I hit my base case. That is, when I call dec 1, if n is equals to 1, if given n is equals to 1, then simply print that value of n, that is 3, 2, 1, yeah, print the value of 1, after return. That's all. So first of all, what I need to do, first of all, I am printing the value of n. So I am going to print system.out.print n value. After that, I will call my dec print. Dec print is my function name, right? Dec print. In this, I am calling my n minus 1, right? I am calling n minus 1. After that, the base case here is if my n is equals to 1, then simply print the value of n. After that, simply return, come out of my program. That's all. So this is the pseudo code. This is the pseudo code for my given question. Now let us code this thing. After that, we will analysis how memory takes place and how call stack takes place in recursive approach for this particular question. So in this, first of all, I am going to create my dec print function. For that, I am going to create my public static void dec print. In this, I am passing n value. After that, here first of all, let me write my base case. So the base case is if my n value, that is n is equals to 1, then basically system.out.print print the value of n. After that, return. After that, return, simply return come out of my program. Else, if my n is not equals to 1, then I need to do my work. The second step is work. So here I need to print system.out.print value of n. After that, after doing my work, I need to call my inner function call. So this is my third step. So I am going to call my inner function. So simply call dec print n minus 1. Right, save this thing, and here I am going to give int n is equals to 10. After that, I am going to call my dec function. In this, I am passing n value. Now let me save this and run. You can see that I have printed 10, 9, 8, 7, 6, 5, 4 from 1 to 10. So this is how the base case, if n is equals to 1, then return the value of n. After that, what work I am doing, if that particular n value is not equals to 1, then it will came out of it don't go into for if loop. After that, it will print the value of n. After that, I will call my inner function for n minus 1. Suppose let us consider that n is equals to 10, then I will call, after printing the value of 10, I will call for 9, and and I will print the value of 9. After that I will call 8. So these process will get continue until my n value will become 1. If my n value become 1, then I will come into my if statement. After that I will print the value of n. Finally I will return my loop. I will return my function. I will return or came out of my function, come out of my function. Now let me explain you in stack format. Recursion calling takes place in stack format. Now let us see, let us do a little bit like a dry run kind of thing for my given code. Here this is my base case and this is my work and this is my inner loop. So these are the three things that I have told you. Now first of all, the control is in main program. So in the main program, this is my main program. So function calling takes in the place of, in the form of stack. So you can see stack in like everyday life, here we have like a pile of books. So putting books on top of each other, that is stack of books. You can see that some people play games like they put stones on top of each other, that is a stack of stones. Similarly here what I will do here, the function calling takes place in the form of stack. So initially the control is in main program, right? Main program. After that here whatever the variables we have in the main program, that is n is equals to 10, will get passed to my deck function. Deck function, here the value is 10, right? Here let us consider that this is my output. This is my output. Here if I'm checking n is equals to 1. No, here n value is 10. Okay, n value is 10. So it will not go into my if statement and it will come and print the value of 10. So what I'm doing, I'm printing the value of 1. After again I'm calling my deck of n minus 1, that is 9. Now n is equals to 9. Here n is equals to 10, right? Okay, this is my deck now. So I am checking if n is equals to 1. No, n is not equals to 1. Then what I am going to do, I am going to print the value of 9. After that I will call for 8. So my deck will become n minus 1, that is deck will become 8 now. So n is equals to 8 now, right? And again I am checking if my n is equals to 1. No, again print the value of 8 and call for 7. So deck of 7. Here n is equals to 7, right? Again n is not equals to 1, print the value of 7. After that here n will become 6 and deck of 6, right? Again not equals to 1, so n will is equals to 5 and deck of 5. So here I will print 6, after that 5, and again deck of 4 will get called and n will become 4. After that here n will become 3, so deck of 3, right? Here I will print value of 4 after 3. Again here I am getting out of the board, but yeah, deck of 2. So n is equals to 2. N is not equals to 1 again. So I will print the value of 2. After that I will call here again n, for this is my final call. I am writing here that deck of 1. So here n is equals to 1. Yeah, the value of n is equals to 1. So what I will do, I will print the value of n. First of all, in the if statement, print the value of 1. So I am going to print my value of n. After that I will return from 1. I will return here. After that I will return this value, this control will get returned like this, right? Finally to my main program. So you can see that I am going from top to down and I am combining all my solutions. I am printing the value of 10. So by returning the final flow or the control will be on main program, and you can see that I got my output like this. So this is how the stack calling works for my recursive functions. Now I want to tell you a little concept of stack overflow. There's a concept of stack overflow. So when we are studying recursions, it is very important to understand what is stack overflow. Right? Stack overflow is nothing but when we call like many stacks such that our memory will get filled. That is nothing but stack overflow, and there is no space to store any variable or any kind of like method or any function calling. There is no space for any function calling. There is no space, or there is no space for creating a variable. Right, that condition or those kind of things is known as stack overflow. Let us consider that I am calling like main function. From the main function I am calling my function, and again from the function I am calling my function, and from the function I am calling my function, and these function calling taking place. And when I got why I get stack flow of, for a particular recursive function. The reasons why we get stack flow is first one, high size or parameter, huge parameter. So the first condition is huge parameter. So if I'm calling or passing parameter like a size of like 1000 or 10,000 array elements, then these parameter is cool. So at every call, every function call, these parameter is passing, right? So if I pass a huge parameter, then there is a probability that I will get stack overflow. After second one is too many function calling, too many function calls. So if I'm calling like at the same time I'm calling like 10 function calls, then I will get a stack overflow condition. And the third condition is if there's no base case. So these are the three conditions for which we will get stack flow. So if we are passing a huge parameter, then there is a probability that we will get a stack overflow. After that, the second condition is too many function callings. Like if I am calling at the same time I am calling like 1000 functions, then it will give me like a stack overflow condition, right? And the third one is if there is no base case. Suppose I am calling a function. In the previous example, you can see that the base case is if n is equals to like uh, n is equals to 1, then what I am doing, I am returning, right? Okay, suppose let us consider that there is no base case, then what output we will get? We will get, right, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, minus 1, and this will continue up to minus infinity, or my stack will get overflow, and these like stack will get full, and it will show us error that there is no space for like storing or printing any function call in my recursive function. So it will show us error, and it will occupy all the memory for in my computer. So if any of this condition is true, or if any of this condition will happen, then our program will show us a stack overflow condition. Now let us do our second question. So that is this is like similar to my first question only. Here what I am doing like first of all, here in the place of increasing, in the place of decreasing, I need to write, I need to print numbers in my increasing order. Suppose like a user has given me n is equals to 10, then I need to print my numbers like 1 2 3 4 5 6 7 8 9 10. So this is how I need to print my numbers. So the approach is same, right? The approach is same, but there is only like a small line difference. Now let me write my function. First of all, I will write my pseudocode, that is public static void increasing. So in the increasing function, I am passing my parameter int n. After that, I am checking if my n, this is my base case, if n is equals to 1, then what you will do, print system.out.print value of n. After that, return. That's all. After that, first of all, in the previous question, what we used to do, we used to print the number. Here we're not going to print. First of all, we'll call the function. After function calling, we'll print, right? So first of all, we'll call increment or increasing order n minus 1. After that, we will print system.out.print value of n. So this is how the pseudocode. Here the only one change, interchange in line, will give me the numbers in decreasing order or in increasing order. Now let me code this thing. Here I am going to write increasing order. So I am going to create my function public static void inc print. In this I am going to pass my n value. After that, first of all, I need to find out my base case. So my base case is if my n is equals to 1. If this condition is true, then what we have to do, we need to print system.out.print, print the value of n. After that, return, come out of my program, right? That's all. After that, what work I need to do here, right? Before I need to do work, first of all, I am going to call my inner function, right? Function calling, right? I'm going to call increment n minus 1. After that, my work, what is the work I'm doing? I'm printing the value of n. That's all. Now in the place of calling, in the place of print the value of n, and in the place of calling decrement print, now I'm printing or calling increment or increasing order pattern. Now let me save this thing and run. So you can see that I got my output as 1, 2, 3, 4, 5. So up to 10. So this is the code for printing numbers in increasing order. This is the code. Right. Now let us solve our next question. Let us understand. Let us do a stack analysis and let us understand how the function calling takes place in our program. So this is my base case and this is my inner loop calling after it, inner function calling after it. This is my work I am doing. Now here initially the control, let us consider that this is my output. Now initially the control is in main program. The value of n is equals to 10. Right. Now I am calling my function, that is increment 10, increment print. So increment print will store the value of 10. After that here n is equals to 10. So this thing will call, this thing will check if n is equals to 1. Yeah, no, n is equals to 10 here, so it will not go into if statement. After it, the second thing is the flow comes from top to down. So here you can see that I am calling my function first. So here it will call inc print, it will pass 9. After that n will become 9. After that here I will pass inc 8, n will become 8. After that inc 7, so n will become 7. So this function calling takes place like this. Right. After that inc 6, here n is equals to 6. After that inc 5, n is equals to 5. After that inc 4, n is equals to 4. This function calling will continuously go until I reach my base condition. So inc 3, n is equals to 3. After that inc 2, n is equals to 2. After that inc 1, now n is equals to 1. You can see that here if the inc is equals to 1, then print the value of 1. Right, print the value of n. So this thing will print me the value of 1. So in the output I will get value of 1 and the control will get hand over to my this previous call function. So this is my previous call function, right? So the function control will come to n is equals to 1 to my previous call, my previous function call. So from this here I will print the value of n. So what I am doing, you can see that I am printing the value of n. So I will print 2. After that I will print 3. After that I will print 4. After that I will print like 5. After that I will print 6, 7, 8, 9, and finally I will print 10. So the output will be 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is how from top to down I have been like calling my function until I reach my base condition. If I got my base condition, what I am doing, I am printing the values of n. So from base case I am returning back, right? As I return back from my base case, I am printing the value of n at each function call, right? Okay, this is how I am printing and this is the work I am doing in this program. I hope you have understood like how stack works. Right, let us do our next question. So in this question I already know that to calculate the factorial of a function. In the beginning itself I told you, right, factorial of n is equals to n into factorial of n minus 1, right? Okay, here the code will be the pseudocode, right? I will calculate the n minus 1 value, that is n minus 1 into factorial of n minus 2, and this continuation function calling will take place until I get factorial of 0. So we already know that factorial of 0 is equals to 1 and this will become my base case, right? This function call will continuously takes place until I got my base case. After it, from that I will calculate the factorial from function calling to my previous or returning control to my previous functions. Right, this is how the code or the concept of factorial of a calculating of a given number work. Now let me write the pseudo code of this question. Right, first of all I will write public static int type function, because I am going to write give a return integer type function to my user. After that I am going to write fact. In this I am passing n. So what is my base case here, that if my n will become 0, if my n becomes 0, then I am going to return 1, that's all. Else this is my base case, this is my base case. After that I need to calculate the factorial of n minus 1, right? Okay, so I need to calculate int factorial of n minus 1. So this will become fact of n minus 1. So I am calling my function. After that what I am doing, I am calculating my factorial, that is f of n. Factorial of n is equals to n into that is nothing but factorial of m minus 1. It finally return whatever the value I got as my function in my function calling. So this is the pseudo code for calculating the factorial of a given number. Now let us code this thing. I'm going to write factorial Right, first of all I'm going to create my function public static int type function, because I'm going to give a return an integer. After fact, in this I'm passing int n. After that here the base case is, first of all, base case is if n is equals to 0, then return 1. That's all, return 1. After that I need to calculate my factorial of n minus 1. For that factor I am creating a variable that will store the factorial of n minus 1. So factorial of n minus 1 is equals to fact of n minus 1. After that what work I need to perform, I need to calculate like this is my function calling here. Here this is my inner function call. Okay, and here I need to do my work. What work I am performing? The work I am doing is int. I am calculating the factorial of the number, that is int factorial of nth number is equals to n into factorial of n minus 1. That's all, and finally return fn, factorial of nth number. Now here I am going to pass n is equals to 5. So in the first video we have written that the factorial of given n is equals to 5 is 120. Right, I am going to print whatever the value that my function return, factorial function will return. Now let me save this thing and run. So you can see that I got my output as 120. So this is how we will calculate the factorial of a given number, and this is the program for calculating the factorial of the given number in the recursive approach. So we have studied iterative approach and the recursive approach of calculating factorial of a nth number, right? Now let us do a stack analysis for my factorial of the given number question. So this is the code, right? So public static int, in this we are passing the n number to find the nth factorial of the given number. Yeah, in the previous example we have passed like 5, right, and we got our answer as 5 factorial as 120. So in this, first of all, we are considering our base case, that is if n becomes 0, that we already know that 0 factorial is equals to 1. This is our base case. So in this case return 1. After that I am calling my inner loop for n minus 1. After that here this is the work I am doing. This is my inner call and this is my work. After that finally I am returning the factorial of the nth number. Now let us do a stack analysis. First of all, the flow or the control is in my main program. And n is equals to 5. Right. So here I am calling my function, that is factorial of nth number. Here factorial of nth number, and I will pass 5. So here I need to find out 5 factorial, but I don't know. You can see that here n is not equals to 0, so it will not go into if statement. After it will come out, and I am going to calculate f of n minus 1 factorial. So f of n minus 1 factorial, that is I am calling f of here n is equals to 5. Now I am calling factorial of 4. So I also here n is equals to 4, and I don't know the factorial of a 4. That's why again a stack call will take place. Here n will become 3, and I am calculating factorial of 3, but we don't know the factorial of a 3. So again a stack call will take place, and n is equals to 2 and factorial of 2. So here you can see that n is not equals to 0. So these call frames will continue until we get the base case, until we touch our base case. So n will get reduced to 1, n will become 1. After that I am calling factorial of 1, but I don't know the factorial of the given number. So here n will become 0 and factorial of 0, right? Factorial 0. So when n is equals to 0, what I am doing, I am returning 1 here. After that I am calculating this. Now I am doing work. So after calling all my inner calls, now I am doing my work, right? I am performing my third step, that is factorial of n is equal to factorial of n is equal to n into factorial of n minus 1. So factorial of n minus 1 is nothing but n I am calling, right, those values I am returning, right? I hope you have understood, right? So factorial of n is equal to n into factorial of n minus 1. So whatever the value that my call stack will return, that will become a factorial of n minus 1. Okay, right? Here I will return 1. After that I am performing n into 1. So this thing will return me 2. So here I am performing n value is 2, and here this value will give me 1. So 2 into 1. So here I will return 2. After that here n value is 3. So 3 into the returned value, that is 2. So here from this I will return 6 and multiply it with n value. Here n value is 4, so I will return 24 here and I will multiply it with 5. So finally I will return the value to my main program, that is 120. So this is my answer. So this is how call stacks or call frames, a box of this each box is known as a call frame, a call frame. So this is how call frames or calling our inner functions take place. After whatever the inner function returns the value, I am multiplying with the current n value. Right, here you can see that the n value is 1 and the returned value is also 1. So I am multiplying 1 into 1. But you can see that here n value is 5. But I am multiplying with the returned value. Here the returned value, that is nothing but factorial of n minus 1 is equals to 24. So I am multiplying with the 5 into 24. So these thing will give me 5 factorial. So this is how I can able to calculate the factorial of the given number. Now let us dive into our next question. That is, in this question we have to print the sum of n natural numbers. Now let us take example that how we can calculate, or what are the things that we need to understand before we dive into the logical part of this code. So let us take example that user has given as 5. So n is equals to 5. Then sum will become 5 plus 4 plus 3 plus 2 plus 1. That is nothing but 5 plus 4 plus 6. So 9 plus 6, so these things sum will become 0. When n is equal to 5, sum will become 15. Sorry, sum will become 15. So I need to return 15 to my user. So can I write that, let us consider that I am creating a function to calculating my sum of n natural numbers. Let us consider that sum of n natural numbers is equals to n plus sum of n minus 1. Right, this is the logical thing. Right, suppose let us consider that I need to calculate the sum of n first 5 numbers. So can I write that my sum 5 is equals to 5, sum of 5 is equals to 5 plus sum of 4. So if I find a way to calculate these sum up to 4 numbers, sum of first 4 numbers, then it can be possible to calculate up to the 5 numbers. Right, so what I do, I will just add and I will do a recursion call for the rest of the numbers. So to calculate the rest of the numbers, I will call my recursion. Right, and I will add whatever the value these things will return, I will add with my 5 value, and these things will give me the sum of the given number. Okay, this is the logical part of this question. This is the logical thing. Right, so can I write that sum of 5 is equals to sum of 4? Right, how we can calculate sum of 4? Can I write that sum of 4 is equals to 4 plus sum of 3, and sum of 3 is equals to 3 plus sum of 2, and sum of 2 is equals to 2 plus sum of 1, and sum of 1 is nothing but 1. Right, so when this is my base case, this thing is my base case. So the pseudo code, I hope you have understood the logic that recursion calls will take place until we get our base case, that is sum of 1. So if I call a function that is n value will become 1, then that is my base case. From that I will return 1. Right, so from this I will return 1. So this value will become 1 and this thing will become 3. So sum of 2 will become 3. Here this value will become 3. After sum of 3 will become 6. So I will return 6 here, and sum of 4 will get 10. Right, after here I will return 10. After I will add 4 plus 10. So this thing will give me 10. So sum of 5 will become 15. So let me represent it in a clear diagram. Right, so yeah, so can I write one thing that sum of 5 is equals to 5 plus sum of 4, and sum of 4 is equals to 4 plus sum of 3, and sum of 3 is nothing but 3 plus sum of 2, and sum of 2 is nothing but sum of 2 plus sum of 1. Okay, and this thing will return me, this is my base case, so this thing will return me 1. So I already know that when sum of 1 when n will become 1, then sum of 1 is equals to 1. This is my base case. Right, from this this thing will return me 3. After 3 plus 3, so this thing will return me 6 and 4 plus 6, so this thing will return me 10, and sum of 5 will become 5 plus 10, so sum of 5 will become 15. So this is how call tags or calling our inner function works. Now let me write the pseudocode for this thing. So I am going to return the value of my sum, right? So I am going to create public static integer type function. After it, let me write the function name as sum. After it, here I am passing int n. So the base case here, base case is if our n is equals to 1, then return n, right? This is my base case, and what I need to do, I need to write just simply return the value of n plus sum of n minus 1. So I am writing this whole thing in a single line. I hope you have understood, or I can write this particular thing in a long form also if you want. I hope you have understood the base case. Now I am going to expand this thing. If you have any problem with this single line, I am going to expand it such that it will become even more clear to you. So here I am calculating sum of n minus 1. So int sum of n minus 1 is equals to or in other words, int sum of n is equals to n plus sum of n minus 1, right? After return sum of n. That's all. Now let me code this thing. I hope you have understood the logic. Now if I code when we code this thing, it will become even more clear to you. Now let me create my function for sum of n natural numbers. So first of all, I am going to create my function public static int sum. In this I am passing int n value. After it, first of all, let me write my base case. Base case is here I need to give static. Yeah, static. After it, here public. So in the base case, if n is equals to 1, then return n, right? After it, my inner function calling, inner function call, and I am doing the work at the same time, right? Work in the same statement. So int sum of n is equals to what I told you, that sum of n is equals to n plus sum of n minus 1. So n plus sum of n minus 1. So I can write it as a sum of n minus 1, right? Okay. After it, finally return sum of n. That's all, right? Here I am passing n is equals to 5, and I am printing whatever the value returned by my sum function. That's all. Now let me save this thing and run. So you can see that I got my output as 15. So this is my function to calculate the sum of n natural numbers, and here I am in the main program I am passing n is equals to 5. After that I am printing whatever the sum value that got returned by my sum function. I hope you have understood the logic and the working. Now let us do a stack analysis for this thing. Consider this is our code for calculating sum of n natural numbers. After it, this is base case that if n will become 1, then return n value, and this is my inner function calling and my work, and finally I am returning sum of n value, right? Let us consider that n is equal to 5. So this is my, first of all, the initial control will be in my main program. So here n is equal to 5, and I am calling my sum of n number. So here n value is 5, so my one function will get called, right? Here n is equal to 5. So I don't know the value of sum of n value of 5, right? Sum of 5. So what I am calculating? I am calculating 5 plus sum of 4. So this function will call me sum of 4. So sum of 4, here n value is 4. Now here what I am calculating? I am calculating 4 plus sum of 3. So I don't know sum of 3, so this function will call me sum of 3 numbers. Here n is equal to 3, and what I am doing? I am doing sum of 3 plus sum of 2, that is n minus 1. After here this function will call me sum of 2. So sum of 2, here n value is 2. After I am calculating 2 plus sum of 1. So here I will calculate sum of 1, and I already know that my base case that sum of 1, here n value is 1. When this value become 1, then what I am going to do, I am going to return 1 to my user, so 1 to my previous called function. So here I will return 1. From this I will calculate the returned value plus n value, that is 2 plus 1. So from this I will return, that will become 3, so I will return here 3. After that I will calculate 3 plus 3, the returned value is 3, right? So n value plus the returned value, so 3 plus 3, so this thing will give me 6. After that here the n value is 4, so 4 plus returned value, that is 6. So this thing will return me 10. After that I am going to calculate n value, that is 5 plus 10, so this thing will give me 15. So I will return 15 to my main program, and I am going to in the main program you can see that I am printing the value or the returned value, whatever the user has returned me, that value I am printing. So I am printing 15 to my user. So this is how stack calls takes place for sum of n natural numbers. Now let us talk about a very interesting question, and this is like very classical question, that is finding or printing nth Fibonacci number. So what are Fibonacci numbers? So the Fibonacci numbers looks like this. So the sum of two previous numbers, and the number starts with 0, 1, and the third number is 0 plus 1, that is 1, and the fourth number is 1 plus 1, 2, fifth number 2 plus 1, 3, sixth number 5, 8, 9, 10, 11, 12, 13, and so on, like this. So the third number or whatever the number is, that number is equal to sum of previous two numbers, and this number is sum of two numbers, and this number is sum of these two numbers, and 5 is equal to sum of these two numbers. So this is how Fibonacci series takes place, and Fibonacci is like a very important series when it comes to sciences, computer science, and like in biology, physics, math, all those things. You can see like in nature, if a person is considered to be handsome, then because then that person has a like a great golden ratio, or the value of his face, or according to the calculation, the face structure or the values of his face is equivalent to golden ratio, and golden ratio is nothing but equivalent to, you can say that, Fibonacci series. And you can see that in flowers, flowers are formed like flowers. You can see that flowers have petals, and whenever you observe that flower petals are in the form of Fibonacci series. And in our DNA is also like some kind of related to, I don't know what exactly, but related to Fibonacci series. So Fibonacci has a lot of like significance in sciences, and it is an important question. So here the question tells that we need to calculate the sum of nth number, or sorry, we need to find the nth number of Fibonacci series. Let us start our like indexes from 0. So here 0, 1, 2, 3, 4, 5. So user, suppose like let us consider that user asked me the fifth term or like sixth term of my Fibonacci series, then I will print 8 to my user, because at the sixth term the value which is present is 8. So I will print 8 to my user. So this is the basic logic of my question, the basic like asking of my question. Now how I am going to do this question, or what are the things that I will require to perform this question. So to do this question, you need to understand the concept of Fibonacci. So in simple words, Fibonacci is a series in which the upcoming numbers is equal to the sum of previous two numbers. Here you can write, suppose let us consider that 0, 1, 2, 3. So third term is equal to second term plus my first term. That is nothing but Fibonacci of third term is equals to Fibonacci of second term plus Fibonacci of first term. So this is the basic fundamental formula, or whatever you can say, right? Basic logic of this question. So this is the like formula for finding the nth number. So in other words, can I write that my Fibonacci of nth number is equals to Fibonacci, what I told you, that Fibonacci of nth number is equals to the sum of previous two numbers, previous consecutive numbers, previous consecutive sum of those numbers. So can I write that Fibonacci of n is equals to Fibonacci of n minus 1 plus Fibonacci of n minus 2, right? Okay. This is the formula for finding my Fibonacci of nth number. So can I write, imagine my recursive function like let us consider example that Fibonacci of 5 is equals to Fibonacci of fifth term is equals to, that is nothing but fifth term is 5, is equals to Fibonacci of 4 plus Fibonacci of 3, that is nothing but n minus 2. Okay, so can you observe one thing, that the initial numbers of Fibonacci series is 0, 1. These are my initially starting numbers, and from those numbers I will get whatever the numbers I got up to nth number. I can like reduce those forms into these two numbers. Yeah, because these numbers are the starting point of my Fibonacci number. So can I write that upcoming numbers is 0, 1, 1, after it next number is 2, after 3, 5, 8 and so on, and these two are my base numbers, or in other words base case. So I will continue calling my recursive functions until I will get my base cases. And the base cases are, if my n minus 1 or any of the call stack or any of the function calling, if my value will become 0 or 1, at that particular case I will return that particular value. I will return either 1 or either 0. I hope you have understood. Now let us do a dry run such that you will understand it even more better. So let us consider that I am calling my Fibonacci of 5. I need to calculate the Fibonacci of fifth term. So what I need to do, or what are the things I needed to calculate the fifth term of my Fibonacci number? So to calculate the fifth term of my Fibonacci number, can I say that I need to calculate my fourth term after third term? If I know the fourth term and third term, then I can simply calculate my Fibonacci of fifth term. So can I write that my Fibonacci of fifth term is equal to Fibonacci of fourth term plus Fibonacci of third term? Okay, what is Fibonacci of fourth term? Fibonacci of fourth term is equals to Fibonacci of third term plus Fibonacci of second term. What is Fibonacci of third term? Fibonacci of third term is Fibonacci of second term plus Fibonacci of first term. Right? What is Fibonacci of second term? Fibonacci of second term is Fibonacci of first term plus Fibonacci of 0. Okay. Okay, here can I write that Fibonacci of second term is equals to Fibonacci of first term plus Fibonacci of 0, and Fibonacci of third term is Fibonacci of second term plus Fibonacci of n minus 2, that is Fibonacci of first term, and Fibonacci of 2 is Fibonacci of 1, and Fibonacci of n minus 2, that is Fibonacci of 0. And you can see that if my n value will become 1 or n value will become 0, right? If any of this condition is true, or if I get any of this condition, then say I will simply return n value. I will simply return n value, right? You can see that if you can see that here n value is 1, so I will return 1. After here n value is 0, so I will return 0. So 1 plus 0, so here finally I will return 1. After this value Fibonacci of 2 is 1. After Fibonacci 1 is also 1, so 1 plus 1, from this I will return 2. So Fibonacci of 3 or Fibonacci of third term is 2, and Fibonacci of second term is first term plus we already know that Fibonacci of second term is 1, right? So 2 plus 1, so from this I will return 3. And here Fibonacci of 3 is, we already know that Fibonacci of 2 is 1, so 1 plus Fibonacci of 1, so these thing will give me 2. So finally 3 plus 2, so I will get Fibonacci of fifth term as 5. You can see that my fifth term is 5. So this is how I am going to calculate the Fibonacci of nth number. So let me write the pseudocode such that you will understand it even more better. Here now I am going to write my pseudocode. So I am going to return the nth term present at my Fibonacci series, right? So I am going to write public static int type function fib. Here I am passing int n. So first of all, my base case here is if my n become 0 or n will become 1, then return n. Simply return n. After that, what I need to do, I need to calculate Fibonacci of n minus 1, Fibonacci of n minus 2, and add those two. That thing will become Fibonacci of n. So can I write that my int Fibonacci of fib n is equals to fib of n minus 1 plus fib of n minus 2. Right, after it finally simply return fib of n. So this is the pseudo code of my Fibonacci of nth term. I hope you have understood what is Fibonacci numbers, what is the logic to find Fibonacci numbers, and the pseudo code. Now let us code this thing. So I am going to create Fibonacci number. After that, first of all, I am going to create public static int type function int Fibonacci of n. After that, I am passing here n. And finally, first of all, let me write my base case. Base case if my n value n is equals to 1 or n is equals to 0. If any of this condition is true, then return n. That's all. After it here, my work. What work I am performing after my inner calls. So the work I am performing is, first of all, I am going to calculate int fib n value. Fib of n is equals to fib of n minus 1 plus fib of n minus 2. After it, return fib of n. That's all. Here I am passing n is equals to sixth term. We already know that the sixth term is 5. Now I am calling my fib number and printing. Right? Fib. Here I need to give static. So we already know that the sixth term is 8. Right? Fib n I am passing. Now let me save this thing. Here I need to give statement terminator. Now save and run. So you can see that I got my output as 8. So we already know that the sixth term which is present at my Fibonacci number is 8. So this is how we are going to calculate the Fibonacci of nth number. Now let us do a stack analysis for this thing. So these are my Fibonacci numbers: 0, 1, 1, 2, 3, 5, 8, 13, and so on. And this is my zeroth term, first term, second term, third term, fourth term, fifth term, sixth term, and in the previous code we have find out the sixth term, that is 8, and so on. Now let me write the code, or let me print the pseudo code here. This is the code, right? This is the code. Here I am passing n value, and this is my base case. If any of this function calling will become n or 0, then I will return like n. After that, here I will calculate Fibonacci of n. After that, n minus 2, and I will return the Fibonacci of nth digit or nth term present at that value. Right? Okay, this is how the code works. Now let us do a dry run or a little bit stack analysis. I want to tell you one thing, that Fibonacci series calls takes place in a form of a tree, kind of a tree like structure. Let us see that here I am passing here let us consider that n is equal to 8. So I need to find out the value, or here I am passing, let us consider that n is equal to 6. So I need to find out the sixth term value present at my index. So I already know that the value which is present is 8. So I need to print 8 to my user as my sixth term. Now here I am passing 6, right? So some stack calls takes place in the form of a tree, right? A tree like structure. So 6 will call 5, that is nothing but Fibonacci of n minus 1. After it, Fibonacci of n minus 2, that is 4. After it, 5 will call Fibonacci of n minus 1, that is 4, and Fibonacci of 5 minus 2, that is 3, and 4 will call Fibonacci of n minus 1, that is 3, and Fibonacci of n minus 2, that is 2, and here 3 will call Fibonacci of n minus 1, that is 2, and Fibonacci of n minus 1, that is 1, and 2 will call n minus 1, that is 1, and n minus 2, 0. After that, 2 will call 1, and 2 will call 0, and 3 will call 2. After that, 3 will call 1, and 2 will call 1 and 0. After that, 4 will call n minus 1, that is 3. After that, here n minus 2, 0, and 3 will call 3 minus 1, that is 2. After that, 3 minus 2, that is n minus 2, right? So this thing will call 1. After that, here we will call 1 and n minus 2, 0. After that, here we will call 1 and 0. So this is how calls will take place, and the diagram looks like kind of complex, but it is simple in other words. So here what is the base case? So this is my base case, right? If n will become 1 or n will become 0, then simply return the value of n. So here n is equals to 1, so I will return 1. Here n is equals to 0, so I will return 0, and I will add these two values, that is 1 plus 0. So here from this I will return 1, and this thing will return 1. So I will add these two values, that is 1 plus 1. So this thing will give me 2, so I will return 2 here. After that I need to calculate this also, that is 1 and 0. So this thing will return me 1. So 2 plus 1 is equals to 4. So this thing will return me 4, and I need to calculate 3. We already know that Fibonacci of third term is 2. So this thing will return me 2. So 5 plus 2. So this thing will return me 6, and Fibonacci of 4, wait a minute. Yeah, Fibonacci of 4. Here I need to call, yeah, okay, good. Right, Fibonacci of 5. Okay, sorry, 3 will return me 1. Sorry. 3 will return me, right, 5 minus 2, right? So this thing will return me 1, and I will return here 5 value. So I will return 5 here. After it, you can see that the fourth term. So fourth term will return me 3. So finally the sum will become 5 plus 3, and I will return 8 to my user. So the sixth term is 8. So yeah, the sixth term will become 8, and I will print that value to my user. So this is how a huge function, a huge tree-like structure or a function calling takes place for my Fibonacci numbers. And you can see that here I am calling like 4 one time, second time, and like if I am calling 4 two times, and I am calling 5 one time, and I am calling 6 one time, and I am calling 3 1 2 three times. After 2, how many times? 1 2 3 4 5. 4 5 2 5 times. After 1, like 1 2 3 4 5 6 7 8 8 times, and 0 1 2 3 4 5 0 5 times. So I am calling the same value again and again. Here in one function call, I got to know the value, and in spite of that value, in spite of knowing a particular Fibonacci of nth term, I am calling it again. This is because this is not efficient like code. Let me show you. So here in the place of n, let me pass like 70, at least 70th term. Now let me save this and run. You can see that my output is not printing. It is like taking too much time to print, because for 70 it will form a like huge calls takes place, huge number of calls will take place. What I told you, that the three conditions are: if the function call is too big, after that the second is if we are passing huge parameter, or third one is if we didn't give the base case. If any one of this condition is true, then we will get a stack overflow. Here we are calling like a tree like structure, like we are calling too many nodes or too many like numbers of nth terms. When I pass 70, 70 will call 69 68, and 69 will call 68 67, and these calls like continuously call each other and try to find out the value, and this process will become so complex that it is taking like too much time for my computer to calculate. Suppose let us take here, I am giving like 25. So it can calculate easily. So you can see that I got my output as 75,000. Let us take let me print here. I will copy the same value here and print, and here I am passing n minus 1, n plus 1. I am calling for 26, 27, and 28. Now let me save and run. So you can see that for 25 my value is 75,000. For 26 the value like almost got doubled, like 1,21,000. After that for 27 my value like got like increased to like almost like kind of double, that is 1,99,000, 96,000. After that for 28 my value like got again big, that is 3,17,000. So you can see that my value is doubling each and every call. Each and if I increase the value of n, then my Fibonacci number will get increased by 2 times. So if I call 70, then that is a huge value, huge term. That's why it is taking too much time. So you can see when we study dynamic programming chapter, then we'll do the same Fibonacci series in a very efficient code using some methods and tricks. So this is the basic function calling using recursion, right, to calculate the Fibonacci of nth number. I hope you have understood the logic and the function call of Fibonacci series. Now in this question we need to calculate or we need to find out whether the given array is sorted or not using recursion. Now let us take example for a sorted array, that is 1 2 3 4 5. Now the logic or the thing which we are going to apply is, first of all we are going to compare these two things. So before we dive into recursion, let us consider our iteration approach. So in iteration approach, what we used to do, we will compare, like we will run a loop, our outer loop and our inner loop, and we will compare if my ARR of I is greater than is less than ARR of I plus 1. If this condition is true, then it is a sorted array. If not, then it is not a sorted array. So iterative approach is like simple for this thing. For calculating whether the array is sorted or not, iterative approach will give me like in seconds, whereas recursive approach is like kind of hard, I guess, but it is also a good way, it is also a good efficient code to write. So here the recursive approach is, first of all we will compare the first digit with the second digit. If this is less than, uh, uh, if 1 is less than 2, then we'll put a recursive call for this array. For this array we'll do recursive call. After that we'll compare these two things. If this thing is true, then we'll apply the recursive call for this thing, and after it we'll apply if these two things are less than, or if these two things can satisfy our condition, then we'll apply this sorted these for recursive call, the rest of my array for recursive call, and after it for this array, yeah, a single element, so the given array is sorted. So this is how we will find out the whether the given array is sorted or not. Now let me write the pseudocode such that you will understand it even more better if I write the pseudocode. So our pseudocode will start public static boolean type function. I am going to return either true or false. If the array is sorted, then I will return true. If not, then I will return false. So public static boolean is sorted is my function name. After that I am passing here int arr, after its index, initial index I. Here I'm the base case is yes, if I got my if I completed all my iteration for the complete array, then what it means, if I get to like apply all my recursive calls for the whole array, it means that the given array is sorted. Okay, so if my array, if arr dot length is equals to I, if this condition is if I got this condition, then I will return true. After it I'm checking if arr of I is greater than arr of I plus 1. If this condition is true, then it means that the given condition or the given array is not sorted. That means that it looks like this. If the array, our array looks like this. If we got condition like this, then we will return false. Return false. After that we will return, finally we will call the function for our same array, that is sorted. We will call for the rest of my array, that is nothing but arr of I, arr. After that we will increase the I value, that's all. This is the code, this is the pseudo code. So what I am doing here, let us consider that 1 2 3 4 5. First of all I am checking these two. If this condition is true, if that is 1 is less than 2, then I will call for my same function, my inner function calling for this array, right? After that I am comparing these two values. If this is also, that is 2 is less than 3, if this is also true, then I will call for this array and I will check these two, right? If this is also true, that is 2 is less than 4, then I will call this array, and if this is also true, then what I am doing, I have called my function for all the array, for all the array elements. So you can see that I have called all the array elements. So starting from this, I have called all the elements. So if I called all the elements and our inner function call is also taking place, then what I will do, I will return true. If any one of this, like I got my base case, like that is 2 is not less than 1, then immediately I will return false. right? This is how our function calling takes place. Now let us code this thing. Now we are calling our function is sorted. So I'm going to create public static boolean type function. Boolean is sorted. In this I'm passing int arr after index int I. Our base case. Now we are going to write our base case. So what is our base case? That if arr or I will become I is equal to arr dot length. If this condition I got, then I will return true. After that, if my like arr of I is greater than arr of I plus 1, then I will return false. After that, what I'm going to do, I'm going to call my function for the rest of my array after comparison. Right here, I'm going to call my function after rest of the array. That's all. Now here let me create my function int arr is equals to, let me give a sorted array 1 2 3 4 5. After that, I'm calling my function, that is whatever the function value that will get returned, I'm printing it, and now I'm calling int arr I is equal to 0. Now let me save this thing and run. So you can see that we got our output as true because we have passed a sorted array. Suppose let us consider that I am passing an unsorted array. You can see that this is the unsorted array. Now let me save this thing and run. So you can see that I got my output as false because the array which is passed is unsorted. Now this is the code for finding whether the array is sorted or not using recursion approach. Now this is how the code works. I hope you have understood the logic and the working of my like is sorted function in a recursive approach. So for iterative approach, we'll run a loop and we'll check for each element. If my arr of I is less than arr of I, arr of I plus 1, then return true or return false. Like that, we use our iterative approach. But here we are checking for arr of I, if any of this previous element becomes like greater than my like upcoming current element, then what we'll do, will return immediately false. After it, we'll call a function for the rest of my array. So if we called like for the whole array, we have called the function calling, then it means that the given array is sorted, right? If it is sorted, then what I'm going to do, I'm going to return true to my user. So this is how the function calling and all those things works. Now in this question, we need to find the first occurrence of a particular element in the given array. Now let us take example to understand like how what is the meaning of this question. Now let us take an array like 8 3 6 9 5 10 2 5 3. So let us consider that this is my array. Right, 0 1 2 3 4 5 6 7 8. So these are my elements present in my array, right? Suppose if the user has given me a key value, that is key is equals to 5, so I will check at each point, I will check at each point I will check whether the given element is our key or not. If it is key, then I will return my index. So here you can see that this is my first occurrence. So you can see that in our whole array 5 has arrived, or 5 we got 5 at 2 indexes, that is I is equals to 4, I is equals to 4, at I is equals to 7 also we got our element, that is 5. So 5 5. So here we returned our index I value, right? Our index I value, that is what is the first occurrence? First occurrence is I is equals to 4, so we will return 4 to my user. So this is how the basic like asking of our question, asking of this question. Now here we need to like return the first occurrence or the first index of my like given element. Here first occurrence of 5 is 4 and the last occurrence is 7. So what is the logic here? So the main logic here is we'll like iterate or we'll like approach each element for the given array. If that particular element is equals to our key, then we'll return its index. If not, If not, then we'll call our recursive function to my rest of my array. Like let me like write here 5, 6, 9, 8, 7, 10, 2, 5, 3. This is my array, right? Yeah, this is my array. So I will check first of all for first index. I will check whether my key here, key is equals to 5, is equals to element present. No, it is not. Then I will call my recursive function to the rest of my array, and I will check for this element. So my key is 5 and the element is present 3. So I will call rest of my array. So the key is 5 and the element is 6. So again I will call the for rest of my array except that particular element, right? Okay, now I will check for 9. Again the element is not equals to our key, so I will call rest of my array. You can see that key is equals to our element, so I will immediately return its index, that is 4, and I will come out of the function. So this is how function calling takes place for my given question. Now let me write the pseudocode for this thing. So first of all I am going to write a public static integer type function, because I am going to return the index of that particular index particular element, right? So int, after it I am going to write first occurrence. In this I am passing int arr, after it int I, that is my index value, after it int key value. That's also if I is equals to arr dot length minus 1. So if I called my all my function for the rest of my array, but I didn't get the value of my particular key, then what I am going to do, I will return minus 1. It means that the element which is not present in my given array. So return minus 1. After that, if our arr of I is equals to key, then return I value. That's all. After that, finally return first occurrence for my rest of the array, right? So I'm passing arr, after that key, same key, after that I plus 1. That's all. So this is the pseudocode for my function. Now let me code this thing. So here I'm going to call public static integer type function int, after that here is first occurrence. First occurrence. In this I am passing our array int arr, after it int key, after it int index. First of all, my base case is if arr, our I, is equals to arr dot length, then return minus 1. If arr of I is equals to our key, then return I value. After it I need to call my function and my work here, right? Work. So I am going to return the rest of my array function calling, that is first occurrence. Here I am passing the same array, same key, but the index is going to change. That's all. Now here I am passing. Let me write my function call first occurrence. Here I am passing my array, same array, and let me pass my key as 3. After it, my index initially is 0. That's all. Now let me save this thing. You can see that 1, 2, 3. It is 0, 1, 2. So for third element, the index is 2. So if I run this code, then I will get my index as 2. Now let me save this. So you can see that I got my output as 2. That is my, you can see that in the array, given array, the index of third element is, that is 0, 1, 2. Right? The index is 2. So I will print it. I have printed the output as 2. So this is how the code for first occurrence is, and this is how it works. Now let me save this thing, and I hope you have understood the logic and the working of first occurrence question. Now in this question we need to find or print the last occurrence of the given element. So this is kind of a reverse question for our previous question, right? This is kind of a like reverse order question. In the previous question we found like the first occurrence of a particular element in my array. Here we are going to find out the last occurrence of the given array, right? Okay. Now let us take an example that the given array is 8, 3, 6, 9, 5, 10, 2, 5, 3. So this is my given array and we need to find the key is here key is equals to 5. So the last occurrence is 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, 6, 7, 8. So the last occurrence is, you can see that the last occurrence is not 4 but 7. So will return 7 to my user as my last index. So how we gonna do this? Here we just bring a small change. Whatever the base case, the pseudocode will remain same, but the only change here is in the previous example we used to check suppose like this, let us consider this is my current element. So in the previous question we used to check whether the current element which is present at my index is equals to my key or not. So we used to check the current element itself. Now here we are not going to check with the current element. First of all we will check with the rest of the array, after that with my rest of my with the current element. So first of all let us consider that here the current element is 4, 8. Let us consider that the current element is 8 at my 0th index. So I will first of all I will not check whether the key is equals to my current element or not. First of all I will check with the rest of the array. If it is present in my rest of the array, then I will print that particular index. If not, then I will check with the current element and I will print that particular index if it is equals to key. So this is the minor difference in first occurrence in last occurrence question. This is a minute difference, that's all. Now the pseudocode will remain same, that is we will write public static integer type function after last occurrence, and this I am going to pass my array the same key after my index. Here the base case will remain same, that is if arr dot length is equals to I, then return -1, that is my element is not present in the array given, that is key is not present in my array. After that I am going to create is found function. So is found function will check for my rest of the array. So last occurrence, here I am going to pass IRR key I plus 1, right? After that if is found is equals to -1, that is it is present somewhat in the array at the last index or at the present AR of I is equals to key. If it is present in any one of the indexes, then what I am going to do, I am going to return I value, that's all. And finally whatever the value I found, I am going to return in the is found function, that's all. It means that here if statement describes that in the last occurrence if the element is not present, or you can see that and if my in the given in the given array the current element is the you can see that, let us take example to understand the if statement. First of all I am checking if my given this is my current element. So the what I told you that we will not check for the current element whether the current element is present or whether the current element is equals to key or not. What we do will first of all check for my rest of the array, right? If it is present the element is present in my rest of the array, then we will print that value, that then we will print is found value, right? Okay. If it is not present in my rest of the array, then what we'll do, we'll print the current element. So if in the if statement we are doing the same thing, we are printing the current element. If it is not present in my rest of the array, then we will print the current element. So if statement will print current element and is found statement will print the element in the rest of the array. So this is the minute difference, and I hope you have understood the logic. Now let us code this thing. So last occurrence. So here first of all we are creating public static int type function last occurrence. In this I am passing array int arr after that int key, after that int I value. Here if my I is equals to arr dot length, then return -1. After that int is found is equals to last occurrence. Same, the array will remain same, only changes the index. After that I am checking if is found is equals to -1, and arr of I is equals to key, then return I. After that return is found. That's all. Now let me save this thing, and here in the place of first occurrence I am calling my last occurrence. And here in the last index I am like here in the place of 0 I am passing 3. So the last occurrence of 3 is 0 1 2 3 4. So if I run this code, then I will I should get the output as 4, because the last index of my last occurrence element is 4. So let me save this thing and run. So you can see that we got our output as 4. So this is how the last occurrence of the given element works. Now in this question we are going to calculate the power of the given number. Let us take the power of the given number as x to the power of n. Now in this question we are going to calculate the power of the given number in an optimized way. In the previous chapter, in bit manipulation chapter, we studied like fast exponent question, right? And in that particular question, we using bit manipulation techniques, we found out the power of the nth number. Now in this chapter we are going to find out the power of the given number using recursive approach. So generally, what is general method to calculate power of n? So we'll run a loop, we'll run a for loop for int I is equals to 0 up to n times, and in this we'll calculate n into n into n into n up to like m times to calculate n to the power of m. So we'll run a loop, and this is not like that much optimized or the efficient code. So in this we are going to learn the optimized code for this thing. So can I write that my x to the power of n, x to the power of n is equals to x to the power of n by 2 into x to the power of n by 2? Yeah, I can write like that. In math we used to study like in exponents and that type of chapter, like integration, we used to study like these kind of formulas. So can I write my x to the power of n is equals to x to the power of n by 2 into x to the power of n by 2? So yeah, this is absolutely right. Okay, and can I write that x to the power of n by 2 is equals to x to the power of n by 4 into x to the power of n by 4, and x to the power of n by like 8 is n by 4 is equals to x to the power of n by 8 into x to the power of n by 8, and x to the power of n by 8 is equals to x to the power of n by 16 into x to the power of n by like 16. And these calling or like this function calling will continue until my n becomes 0, and if my n becomes 0, then we already know that x to the power of 0 is equals to 1. So this will become my base case. So can I write that my x to the power of n is equals to x to the power of n by 2 into x to the power of n by 2, and this thing is equals to x to the power of n by 2 is equals to n by 4 into n x to the power of n by 4, and this process will continue until x to the power of 0 will get. So if I get x to the power of 0, then this is my base case. This is my base case, and from this I will return 1, and the returning will work, and finally I will get my x to the power of n value. So this is the main logic of my code. So let me write the pseudo code such that you will understand it even more better. So first of all I am going to write my pseudo code, that is public static int optimized power. In this I am passing x value and n value int n, right? So what is my base case? That is if my n is equals to 0, then return 1. Okay, this is my base. After that I need to calculate like power of the half power, right? So to calculate half power I am creating int half power is equals to, I am calling my recursive functions, that is uh, power of n a comma n by 2 into optimized power a comma n by 2. Right, after that, this is for my even number. Suppose let us take like x to the power of 5. For that I need to calculate like x by 2 plus 1. So can I write that my, because n is integer, so n by 2 will also become an integer. It don't store like 2.5 or this kind of values. So can I write that x to the power of 5 is equals to x to the power of 1 into x to the power of 2 x to the power of 2. So can I write that x to the power of 1 into x to the power of n by 2 x to the power of n by 2, that is nothing but a here I am passing a, right? Okay, after that a to the power of n by 2 a to the power of n by 2. So for odd numbers can I write like this? Yeah. So for odd numbers, if my n modulo 2 is not equals to 0, then in this my half power will become half power is equals to a into half power. So this is my half power, I am multiplying with half power, that's all. After that I will return my half power, that's all, half power square, that's all. This is how I will calculate the power of the given number. Now let us code this thing. Power of the given number. First of all, I am going to create my function public static integer type function, because I am going to return the power of the given number. Let POW, in this I am calling I am passing int n, after that int a, after that I am passing int n. The base case is if n is equals to 0, then return 1. After that I need to calculate my half power square. Half power square is equals to uh, power of a comma n by 2 into power of a comma n by 2. Right, this is for my even case. If it is odd, that is n modulo 2 is not equals to 0, then my half power will change into half power square is equals to POW of a into n into half power, into half power, that's all. After that I will return my half power square, that's all. Now let me save here, and in the place of array I am passing int a is equals to 2. After that int n is equals to 2. So 2 square is equals to 4, right? So I will I will get my output as 4. So I am calling my function and I am passing a value and n value. Now save this and run. Here I need to give a, right, not function calling, right, a into half power square. Now let me save this thing and run. So you can see that we got our output as 4. So a is equals to 2 and n is equals to 2, and 2 to the power of 2 will give me 4. Suppose let us consider that here I am passing like 20, and let me save and run. So this thing will give me 102 to the power of 20 is 104 8576. So this is how the working of calculating the power of the given number works using recursive approach. I hope you have understood the concept and the working of the power of calculating the power of the given number. Now we are going to do an interesting question and a very important question, that is styling problem. So whenever we are in a party or any kind of thing, some people like remain quiet, they don't talk that much. Those people are kind of introverts and all those things, and some people like very extrovert, they want to talk with everybody, they are making like connections, they are making network and all those things. So in this question also, user will give n number of friends, and each friend can have two choices, that he can remain single, he don't talk with anybody, or remain like single person in the group, or he can make friends, he can pair up with somebody, but he can pair only once. Here is the condition, that the given friend can pair with only one given person. After that, in this question we need to find the total number of ways in which n number of friends can remain single or can be paired, right? So to understand this question, let us take an example that like in a party there is a friend, so a person can like remain single and like just drink and eat whatever he can do, like just check his phone and all those things. He don't talk with anybody, he can do this. But he can also like talk with another person, he can also like talk with that particular person, he can also make like a pair with that person. So these talking or all those things is known as pair, and remaining like all by himself is known as single. So in this question, a person can, given n number of people, a single person can make pair with another person or can remain single, right? So he can have two choices. So here is the condition. In this every friend can only pair once, can only pair once. So let us consider that there are three persons A, B, C. A, B, C. Suppose if A and B like paired with one another, then he can't pair with C, or he can't pair B can't be paired with C, or A can't be paired with C, because these two guys A and B are a pair, so they can't pair with another body because they already got paired, right? So this is the basic requirement or the basic condition of this question. In this question, given n number of friends, we need to find out that the number of ways a person or a given number of n friends can remain single or can be paired. We need to written n number of ways, right? Number of ways that can be possible, like either he can be single or he can be like paired with anybody. And in most of the cases, we guys are single. Okay. Okay. So yeah. Now let us understand the three things. The three things are, first of all, we need to understand our base case. After what work I am going to perform, this is like very similar to our tiling problem. After, the third one is understanding our inner function call. Inner function call. Right? These three things we have to understand. To understand base case, let us take a scenario that let me first of all clear this thing. So to understand this problem, let us take example that there are three persons. There are three persons A, B, C. So A can remain single and B, C can form a pair. After A and B can form a pair and C will remain single, or A and C can form a pair and B will become single. So these are the three ways, and the fourth way can be possible that three of them will remain single. Three of them are introverted guys such that they don't talk with one another. Right? So these are the three ways for given three friends. These are the ways. These are the four ways that can be possible for three friends. So to understand what is base case, or to find out the base case, let us take example that for n is equals to 1. For n is equals to 1, there can be like only one friend. So the number of ways that can be possible, he is only one, so he will remain single. So number of ways will be 1, right? After that, for n is equals to 2, the two persons can remain single, right? They don't want to talk with one another, so instead they will remain separated and they will do their stuff or whatever the things they want, like they can remain single. After, the other way can be the two persons can form a pair, so the number of ways will be 2. After that, when n is equals to 3, we already seen that the three friends, that is A, B and C, like three friends. So A comma B comma C, both of them, three of them want to be single. This is one way. Or A comma B form a pair and C will remain single, or A comma C will form a pair and B will remain single, or B comma C will form a pair and A will remain single. So the number of ways that can be possible is like 4 here. So the base case here is when n is equals to 1, number of ways is equals to 1. So if n is equals to 1, or here when n is equals to 2, number of ways is equals to 2. So when n is equals to 1 or n is equals to 2, then return n as number of ways that can be possible, right? Okay, so I have find out my base case, right? By just taking small assumptions or small like sample size, I can able to find my base case. After the second thing is work. I need to define my work. So the work is at every iteration or at every recursion call, I am making a choice. I'm making a choice, right? A person can make a choice, right? Suppose if I am in the group, I can make a choice. I can either be, I can either want to be single, or I can pair with a particular person. And pair means only two persons. Remember guys that A comma B comma C can't form a pair. Pair means only two people. And if a person pair with another person, then he can't pair with another body because he already paired with some other person, right? Such that he can't pair with like an external person or any other person, right? I hope you understood, right? So at every recursion call, or a person or a given person can make two choices, that either he can remain single or either he can like form a pair. So if he chooses to remain single, then what happens? If he chooses to remain single, then the number of people will be n minus 1. So I need to find out for n minus 1 people how many ways that can be possible, and I can remove this thing because he wants to be remain single, right? If a person wants to be like in a pair, then the two persons a person will form with pair another with another person, another body, and the number of people will left are n minus 2, or in other words I can write f of n minus 2. Okay, so here one more thing we need to understand here, sir, that suppose there are 10 friends in our group. There are 10 friends in our group, and I want to like make a pair with another person. So the total number of friends for me is 9, right? In a group of 10 people, let us consider that I am one of the part of them. So for me there are 9 friends that can be possible to pair with them. There are nine friends that can be there is 9 friends and there are 9 number of possibilities that I can like pair with 9 different people. So here the number of ways can be n minus 1. So if I remove one person, he can able to make n minus friends, n number of n minus 1 number of pairs, right? It can be possible. You can imagine like suppose let us take that there are 3 friends and A wants to be paired with suppose like ABC are 3 persons. So how many pairs A can make? He can make only 2 pairs because there are 2 persons left, right? Okay, similarly here given n number of friends, if n wants to make pair, then their total number of persons left are n minus 1. So he can make pairs with n minus 1 number of friends, right? Okay, n minus 1 into f of n minus 2. So these are the number of ways. So total number of ways will be, the inner function call will be total number of ways is equals to f of n minus 1 plus n minus 1, because n minus of 1 friends can be possible for that particular single person to make pairs. Okay, after f of n minus 2. So this is the function calling, and this is my basic base case, and these are the works I am performing. So this is my first base case, after this is the work I am performing, and this is my inner function call. All these 3 things are clear. Now I can code this thing, so by coding we will understand it even more better. So here I am creating my function friends pair, creating my function public static int type function, because I am going to return the number of ways that can be possible, right? So int friends pair. In this I am passing int n. After my base case is if n is equals to 1 or n is equals to 2, then I need to return n. After that I need to calculate for single friend. For single, single, if he wants to be single, then the number of friends will remain n minus 1. After that this is for my single friend. This is my work, basically this is my work for my single friend. Most of my friends are single, right? Yeah. After that for my pairing, number of pairing, for my pairing int pair friend friend, friend is equals to friend pair n minus 1 n minus 2 After that, here number of friends that can be possible for pairing is n minus 1, right? So n minus 1 into my friend pair, that's all. After that, here I am calculating total number of ways. Total ways int total ways is equals to single plus paired friend, and finally return total ways, that's all. Now let me save this, and in the place of calling number of like friend tiles problem, I am calling my friends pair, and I am passing n. Here let me give n is equal to 3, and we already dry run that for three friends the number of ways that can be possible is 4. So if I run this code, then I should get my output as 4. Now let me save this thing and run. So you can see that we got our output as 4. So for 3 friends, the number of ways that can be possible, either he can remain single or can be paired, are 4. Suppose in the place of like 3 I am giving like 10, then let me save and run. You can see that 9496 possible ways, there are like 9496 total number of ways that can be possible for 10 friends. Suppose let us consider that if I give like 20, now let me save and run, then the total number of ways can be like yeah, it is out of the, like this thing is giving me negative value because this thing is going out of my int range, right? Here let me give like a small value like 12. Now let me save and run. So you can see that the value is like increasing exponentially. So these are the total number of ways that can be possible for given n number of friends. Now these are the like basic recursion techniques. So up to now we have completed our chapter recursion. In this chapter we have understood like what are the 3 conditions to calculate like any function thing, any function calling and all those things. Those 3 things are, first one is we need to understand what is our base case. Second thing is what is the work we are going to perform in our like a function. After the third thing is how our inner function calling will take place, how our recursion will take place. These 3 things we need to be very clear to do any question in recursion chapter, right? After understanding the concepts of recursion, what is recursion, why it is important, and what are some examples of recursions in our real world. After that we proceeded with question like we calculated factorial of n numbers, sum of n numbers, and like even odd, sorted or not, and Fibonacci series, friendship problem, tiling problem, and all those kind of problem, first occurrence, last occurrence problem, and all those important questions we have covered. And I want you guys to do the assignment by yourself. If you didn't understand these questions, then go into internet and try to do the question for yourself. First of all, do it in pen and paper. By using pen and paper, you will understand. First of all, be very clear with the logic. After that, you can proceed with the code. If you are like very clear with the logic and very clear with the intuition of the code or the problem, then you can solve like the code in just minutes, in just seconds you can solve the code. You should be like very clear what is going on in my code, what are the things that I am taking. After all those logic, after you are clear with the logic and you have done your code on the paper, then you should proceed with the VS Code editor, right? Up to now we have completed all the important questions, all the important concepts of recursion. Now we are going to do a simple chapter, at the same time very interesting chapter, that is divide and conquer algorithms. So with that being said, I will see you in the next chapter.